Hi guys. Okay, so in this video, let's understand what the QQ plot is. And yeah, that's all this video is going to be about. So the QQ plot is basically used to test whether a random variable is normally distributed or not. Okay, so this plot comes in a class of visual graphical representations or plots, such as there's another plot called a PP plot that's also used to test whether a random variable is normally distributed or not. But I won't be covering the PP plot in this video or in the next one. But if you still want to know what it is, just write a comment and I'll make another video on it. So let's start with what a QQ plot is. Let's say I have a random variable x, okay? Now I want to test if x is normally distributed or not. It can be distributed in any way, but I want to test if it is normally distributed or not. So let's say that x gives me five, let's say 100, 100, or let's say 500 points. Okay, so I get 500 outcomes from the random variable x. Let's call those outcomes x1, x2, all the way to x500. Okay, so what I'm going to do is, let me first sort this. Okay, sort in ascending order, so that I have my points x1 dash, x2 dash, all the way to x500 dash, and they are all normally, they're all in ascending order. Okay, x1, x2, x1 dash, x2 dash, these are all the points but in ascending order. After this, what I'm going to do is I'm going to take the percentile. Okay, so I'm going to take the percentile at every point. So I'll have, so if I'm taking uh every one percentile, then I'll have 5 points in that, right? So I'll have, let's say, x5 dash as the first percentile, then I'll have x10 dash as the second percentile, x15 dash as the third percentile, and all the way till x500 dash as the 100th percentile. Okay, so I have this. Now what I'm going to do is I'm going to take a random variable y, which is normally distributed with a mean 0 and a variance 1. This also means that its standard deviation is also 1. So I'm just going to take y over here. Y is this random variable. And I know that y is normally distributed. So let's say that y has 1000 points. Yeah, there are 1000 outcomes for the random variable y. Let's call it y1, y2, all the way to y1000, right? Now again, I'm going to sort this. I'm going to sort it and I'll get y1 dash, y2 dash, all the way to y1000 dash. Okay, these are all sorted in ascending order. Again, I'll take the percentiles, and what will happen is um I'll get every one percentile at 10 points. So at y10 dash, I'll get the first percentile, and then at y20 dash, I'll get the second percentile. Okay, this continues all the way to y1000 dash, and this gives me the 100th percentile, right? So you see that there's no difference in the procedure except the fact that we know y is normally distributed. Okay, so now what I'm going to do is I'm going to plot this. Okay, I'm going to plot this on a graph, right? So I'm going to take my y random variable over here on the x-axis, and I'm going to take my x random variable on the y-axis. So this is the theoretical values which we got from the standard normal distribution, and this is the observed values, right? Because the values that we got from the x random variable are observed. So what we're going to do is we're going to plot the first percentile over here, then we're going to plot the second percentile over here, all the way to the 100th percentile. Okay, we're going to plot the 100th percentile here. Now if this, the first percentile, let's say the first percentile falls on this, the second percentile falls here, so on and so forth. If this is a straight line, right, all the way till the 100th percentile, if all of this is a straight line, then we say that our x random variable is normally distributed. If the x random variable doesn't, if the observed values don't fall on the straight line, if they fall elsewhere, like if they deviate this way, right, and then they come back here, right, this is not a straight line, so we conclude that the random variable x is not normally distributed. So that's how the QQ plot works.